Okay, guys, and okay, girls. Um, so the last hiccup, the last problem we had is that okay, we click on this blocker. The barrier, as you can see here on the right, starts deploying. So the mesh gets smaller and smaller for this barrier, and we have a little bit of a problem. Unity world coordinate, local coordinates intermingling is still a little bit confusing to me. So transformations between world and local coordinate space and points and vice versa. This is one subject that I must further study, as you should also. So let's see what we got here. So we got this blocker which is extended in the vertical direction. This is the start line point or vector, and this is the end line. And this line, when the mesh which started retreating, you see it here, intersects this line, or when this point right here you see the upper left corner intersects this line, it's game over for the barrier. It stops going to the right enough right. The path has opened to the left, and our spaceship can travel to the left side of this barrier without getting electrocuted by these lightning bolts, which we have not started coding yet. They're simply changing form and structure, but they're not moving towards our spacecraft as we're approaching. They're not taking any life yet. Excuse me. So I guess probably the most important aspect of Unity is understanding coordinates systems. The coordinate system that Unity uses transforms the difference between Euler angles and quaternions, because in this aspect, these issues caused by confusion or not understanding properly these concepts of world and local coordinate systems in Unity has caused most of my errors and hiccups in starting to remake this game. So coordinates not being what you're thinking they should be, not being what they should be, because you have mistaken them for world coordinates or for local coordinates or vice versa, is the cause, could be the cause of your problems also. So let's start to analyze these coordinates, because as you're gonna see here, the barrier gets past the blocker and does not stop. You see, it does not stop. So let's see why. So a blocker, and we get the paper. as you can see, mm, chocolate is my one of my weaknesses. mm, Dark whole hazelnuts. mm, so this is our blocker. This is the local coordinates system of the blocker. It has the y-axis aligned with the horizontal to the left, so positives go to the left, and the x-axis, the red axis here, goes upwards in the positive direction. If we switch here in the upper right global, we see the world coordinate system, which is rotated 90 degrees clockwise, so that the x-axis becomes the horizontal, but to the left, to the right. So positives are to the right, and the y-axis becomes a vertical with the positives going upwards. See here the green gizmo. So we want this beautiful green laser to stop the barrier, and this red barrier should stop right here. So why doesn't this happen? Because there's something wrong with these points. We check the intersection of this line, horizontal line, with this line, because points get confused between world and local coordinates. The intersection, of course, doesn't happen. So let's check them one by one. So this is the blocker, and let's check its where the let's check its start line and end line. So excuse me a little bit. These are the two variables that interest us. They're called start line and end line, and in our case they represent a vertical segment. And as you all know, a segment is a line that has a start and an end. So start and end. So here, let's see how these points are represented. Here, the constant is y. So is this correct? Should the y part be constant? Well, if we look here in the global coordinate system, it shouldn't. It shouldn't, because this is the start point, and this end point has a different value on the y-axis. So why should this be? Because we're looking at the global coordinates. So this means that these are not the world coordinates. These are some other type of coordinates, local. So star line x, maybe this is the x, and this is the end line. Okay, let's check the blocker position. Not much information. They're localized, as you can see. this first information is that our start and end points are in a coordinate system, which is probably some local coordinate system, because the local coordinate system, as you can see selected here, has the y-axis constant, and this is constant. As you can see, start line, end line, it stays the same. So this means that start line and end line is not converted to what we want. So let's note this. Let's note this start line and end line. Oh, it's a little dusty. It's a little dusty, but no problem. Dust goes away when you rub it sufficiently enough. Start line plus end line, and we're gonna note that the coordinate system, the y-axis is on the left and the x-axis upwards. So y is constant and x is variable. Good. Let's see the next step in our what we're doing here. So what happens next is that okay, this is start and evolve expansion. Okay, let's do it this way, and okay. So we should not start talking with so, but anyway, start and evolve expansion, and this, okay, Okay, modify. Okay, where is this? It's here. Huh? No, here. Okay, it's here in the. Okay, so we have the start line and end line vectors, v vectors, which represent the start and end of the blocker. And we have next in update bouncer, in the case of our bouncer right here, these vectors, which are the start line and the end line, these 2 points. Okay, and what do these represent? They're just going to be extensions. We're just going to double the length of this segment, but retaining the old value of our start and line segments. So we're just going to replace them with these, and let's look at this method. New window. Lock trap. This is it. So let's note them with L, as in the local coordinate system 600. Yeah, okay. Modify variable. So what does this do? First of all, and then let's see if it does it good. So 600, 300, okay. And the coordinate system is x up, to the left, y. Okay. Modify barrier mesh from line. So if the start point is in the lower left, so let's watch our let's study our vertical line. If the start line is down and the end line is up, that means that start y is less than end y, and in this case we're gonna use end start y, which is positive. These are all positives. So if end y is bigger than start y, we'll use end start y. If start y is bigger than end y, we'll use start end y. The same goes for the x-axis projection. So if this is the start y, this is the start point, of course that means it's bigger than in case we're talking about the y in this case direction y vertical, but because these are not the real points, it will not work as they're supposed to work. So something's not right here. So this CRB start line, let's read it. Let's see. CB start line, where is it? It's here. So CB y is constant and x so if y is constant and x is variable, That means it's local coordinate system. The local coordinate system, and we do not want that because it creates confusions between different local coordinate systems. So it should be ideal if all these local coordinate systems were the same, but being inside different game objects, they may have different rotations, different relative positions, so things get messed up. So the best way to go forward is to convert all these local coordinates into general world coordinates. All these local coordinates, convert them into general world coordinates, and then compare them, intersect their lines, etc. So this is what we're gonna do here. First of all, we're gonna make these CBs as we have made them below. We're gonna make them transformed into world coordinate system by using this transform point. So let's do that and check them again to see if they have world coordinate system and not local coordinate system. Let's click on our barrier. Good. It started expanding, so let's check our mesh barrier blocker. Okay, start end, it will still be local, but CB, as you can see, CB has become a global. So because X is on the positive, well, now it's not positive, it's negative. Okay, so CB start end, CB2 start end, CB start end, and CB2 start, CB2 end. These are global system coordinates transformed, and so X is variable and Y constant, because Y is up on the vertical and X is on the horizontal. So this is global and this is local. X, Y. So at least up to now everything is clear. Okay, so these points, which are global world coordinate system transform now, we're gonna pass them to this method that simply extends their doubles their length. So this start CB start and CB end line are simply 2 points, 2 vectors that represent a segment, and we're gonna simply so this is our CB start line, CB end line. We're gonna simply double their length, so they'll become bigger. Why? Because if this is our mesh, if this is our mesh, that way, if this was the segment, we could do no intersection. But now, if it's bigger, it intersects with this line and it intersects with this line, so we can check for barrier blocker intersection. Why double them and not multiply them by 1.1 or 1.2? Well, it doesn't matter. You can double them, you can triple them, you can quadruple them, you can make them 1000 times bigger. You can work with whatever you want, as long as it's logical, it doesn't matter. So let's check the points now. So we had this CB, and we're working on it right here. And let's check start V and NV. It's still the old work coordinate system. Jesus, it's still the old one. Why? Well, let's transform it. Let's make it. Let's make it as it should be. This transform point startix. No, start x, and this is y. Yep, good. And x and y. So this is the first modification, and let's do it also for the overlay, which will simply be the same code but a little modified here. I'm gonna do this. Okay, I'm gonna delete this. This is the next step. We're gonna make even these points. Let's note them. Start V and V. Start VO and VO. This is gonna be global. So let's compile this. Oh, MD. Still not good. That means it's EMD. EMD. Okay, let's check this barrier once again. Oh, it didn't change. How is this possible? It didn't change. No. So I changed the start V and V in the barrier mesh, so this is different. Okay, but no, but yes. Huh. Okay, so let's see if this is right. this is correct, but because correct does not always mean right, maybe left or maybe centered. So in our blocker we are having CB line minus 216. Okay, okay, let's see. And then we are, what are we doing? We're doubling we're doubling their length. That's what we're trying to do. So if we're doubling their length, I'm sorry, but CB star line should be even smaller. So it's supposed to be more toward the negative, and y should be a little bit. So if this is global, no, x should be more to the left, and y should be a little smaller than 900. Okay, and CB and line bigger and y bigger. Then star line, I said, okay, so why are we not seeing this? If we're passing this point, so why? Oh, maybe we're not supposed to do this. Yes, because we already had them transformed. Okay, let's check them now. We take them one by one until we solve this problem. If we solve this intersection problem, that's a big step forward. Okay, so this is the barrier 0, blocker. Okay, this is okay, and look at the barrier mesh. Let's see the star. Okay, good. So x is constant, yes, and y. Okay, let's see. Start V, O, and V, and now start O and O. Okay. But what are we doing here? Start O. So let's note this. With what we start? We start with minus 216. 0.4955 on the x side, and plus 9665024. 966665024. Okay, so this is CB start line, and end line is gonna be here, minus 216.4955, and y 96513. So it will be reversed. This is 216.4955, and 9651309. Okay, and this will be upwards, minus 216.4955, 9665024. So xy. Okay, this is the start line, which is up, and end line which is down. Okay, so this is it. These are the coordinates. And CB2 is the same. I used for the overlay. So this is the situation. Let's see how our so in this method, in this function, what are we doing? We're extending the CBs, and then the CBs will be saved in start V and end V. So end V and start V. Let's check this out. So the X position stays the same because X is constant. X is constant. So it does not concern us right now, the X-axis, because we're only studying the Y-axis, because this is a vertical line in the world coordinate system. So let's see, our start V, which was upwards. Now, instead of 966.5024, it's 995.889. So it's gotten a little bit bigger. But I don't see it double. It's only a little bit bigger. Why isn't it double? Because I will multiply it with this baby, which is 5,000. So we multiplied start minus end or 5,000. Okay. So we made it a little bigger. We're not doubling it. We're subtracting. Let's see, 966.5024 minus 965.1309. This is 1.3715. Multiplied by 5,000, we get 6,000. Oh. No, it's too big. Oh yes, 6,857. Okay. Huh. Let us verify this. So this is mod barrier mesh. It's 5,000. Okay, and this is this, which is no, serve line. So this is okay. This is start and end are these values from here, from blocker. So it's this minus this, which this minus this, it's 966 5024 minus 965 1309. Okay, multiplied by 5,000, 6857. So 6857 because start line is bigger than end line. Y start and Y will be this value 6857.5. So this value 6857.5. We're gonna add to start Y. So if we're gonna add to start Y, why is it so small? I mean, start Y should be much bigger. You see? So not 9665024, it should be 9665024 plus 6000. So why isn't it bigger? Much bigger. Why? Hmm. Hmm? It's supposed to be bigger. Um, anyhow, it doesn't matter because uh, it it gets extended in the upwards and downwards direction. It gets bigger, so it's not 966, now it's 995. So it's a little bit bigger in the upper side and a little bit bigger on the downside. It's not 966, it's 936. So our segment just got a little bit bigger, just perfectly so it could intersect the mesh. Good. Now we have these points, and let's check the next step. After we modify barrier mesh from line left and modify barrier mesh from line left or the overlay, we save these values. Good. So these are our new intersection blocker segments. We have them right here. Look at them. Look. Okay, they're pretty good. They look pretty good up to now. What do we do next? We access this function, this method. Modify barrier mesh from line left detach. So this is the moment after we extend our blocker instantly that we start to make the mesh retract like a little scared turtle. Modify barrier mesh from line left detach. So let's see what we have here. Intersector speed, which is the speed of our mesh retraction, and delta time, which is the interval of time between frame rates. Standard issue multiplication for all position changes, accelerations, speeds. So the movement remains constant and generally the same on all types of devices. Okay, start v1 and v1 and 2, 3, 4. I'm gonna copy this. Okay, here. So it's all good and tidy up to now. We have this CBs. Now we have the start V's, which are transformed into global coordinate systems and extended so they're bigger. Okay, now they are bigger now. So they are bigger. If they are bigger, then we can get to the next step. And this step, now I'm moving the mesh, which is the old mesh was simply a mesh like this. We had in the upper right corner the first vertex, the second actually, the vertex number 1, then in the upper right vertex number 0, in the lower left vertex number 2, and in the lower right vertex number 3. This was Java LibGDX. But now now we're working directly with 0, 1 in the upper right corner, upper left corner, 1 in the upper right, vertex 1 in the upper right, vertex 2 in the lower left, and vertex 3 in the lower right, exactly as in our Java LibGDX. The only difference are the 0 and 1 vertices, which are inverted in our case here, Unity C#. So this is our old model, this is our new model. Not much to say about it. It's a simple mesh, 4 vertices, 2 triangles, and our triangles here are 0, 1, 2, 0, 1, 2, 0, 1, 2, 1, 2, 0, 1. Oh, it's reversed. 0, 1, 2, 2, 1, 3. Okay, it's a simple mesh. Let's get back to our code for the mesh. So we are doing this extension still in a global coordinate system for these points, which are now all global, and we start to add a little bit of access to the mesh, to this line. So we're taking this we're taking this mesh, which is let's say this is the upper line, where simply this is point, the vertex 0, and this is vertex 2. We're gonna retreat them, in my case to the right, in your case you see them retreat to the left, but imagine you're seeing my point of view. We're retreating them to the left, okay, and this is exactly what's happening here. You see, they're going to the right, see, they're going to the right, right, your right, my left, but now is my right, your left, but they're going to the right, and as soon as they intersect this blocker, they should stop here. But this, as you can see, these vertex coordinates are not world coordinates; they're local coordinates, and who knows what what coordinates are in the objects that are their parents, that is their parents. So first of all, let's check on the mesh. Let's check this mesh, the barrier mesh. This is the mesh, this is the mesh actually. So we're lucky because this mesh has the x coordinates. Oh no, maybe we're not lucky. Oh, you are lucky, because the coordinate of the mesh has the same rotation as the, so adding x, the local coordinate system of the mesh has the same rotation as the world coordinate system. So x, local x is global x, and local y is global y. So there's no confusion. I mean, that's why it's working. If we add retreat this mesh by adding x, the local coordinate system being similar yeah, with the whole coordinate system rotation wise, not value wise. Okay, it's gonna add them correctly. So what we need to do here, so okay, we're adding values to the coordinate system. Good. The measure, let's check this. So intersector, let's check these intersectors. What are they? What are they? So intersector, let's make it bigger. So this intersector 56MO is uh, the upper left corner of the mesh. Intersector 1011PO is the lower left corner of the mesh, which is vertex number 2. This is vertex number 0, the first one, 0, 2, and these we're going to extend them, but not them. We're going to create two similar points which have the same y-axis, but oh, this is what I okay, but towards the left with retracted, translated towards the left with mod barrier mesh intersection, which is, let's see it right here, 5000. Okay, so you see what we're doing here. First we're modifying the point, we're making it global, and then we retreat it, but that's not correct. We need to retreat it first, and then we need to transform the intersection. So it's not correct the way I done it. This must be the case, that the reason why our code is not working, and the blocker does not block the barrier. Let's see it pass to the you see the barrier contracts, you see it gets smaller and smaller, and it should stop right here in the middle of the blocker. Let's see, it stops. Does it stop? Will you stop? No, it doesn't stop, because because we are not thinking. We should be thinking. So we should have subtracted this mod barrier mesh intersector before we have transformed the point. Before, because could this be the situation? Let's do it this way. Maybe this is the cause. So let's do it the way we're supposed to. Okay. Equals verdi x minus mod barrier mesh intersector. Good. Y is this intersector 5 okay, y is this okay, and now this will be this, and this is all we need to do for the first one. Yes, because this is 0, so this is the second one. Now the third one, because it's 0, it stays the same. Good. And this one I'll have to modify it first. So doesn't matter. Intersector X is this one, yx minus, good, and y is this, and this because it's 2, it's gonna be this, but no, let's do it correctly so it do not mess anything up or down. It's gonna be 2. Okay, so we solve this one also. This is the correct way to do it. Well, let's do it this way, let's do it this way so you don't mess things up. This is correct because we only have zeros. Let's do it this also, so this will be the next one. Okay, this mathematical simple arithmetical operation can mess you up. Oh, this is the way to do it, and this is the way to do it. Okay, and this is the way to oh okay, oh no, transform what am I transforming? No. Yes. Wait. Vert. Bio 0 0. It's all about. Okay. This is the next one, and this is our last one, which is equal to okay, the whole point. Okay, and this is this. Good. Let's check for any errors of syntax. We have no errors of syntax, so let's check our mesh now. Is it gonna fail on us again, or maybe not? Maybe we'll be lucky. Let's see. Will it stop here as it intersects the mesh of the blocker, or will it go further? Let's also select it so we can see its border, its form. It's okay, so it's there. It should stop right here. Huh? Will it stop? Please stop. Please let it stop. God, oh God, please stop. Please. So a clear example: prayers don't work. We asked God to help us, and He didn't help. It didn't help. So lesson, kids. Religion is maybe bogus. God didn't help us. He didn't stop. Let's see why He didn't stop. So God doesn't help. Maybe thinking will help. Let's think. First of all, let's check these points, intersectors. Let's see if they have any meaning. Let's read. Oh, let's read them from here. Zero. Okay, intersectors. Of of course they don't have any meaning. Oh my god. Of course. Got to T scheme object transform parent transform. Oh my god. It's local but not global enough. Global but not is more local than okay. Nope. Okay. Nope. Let's transform this one more time. This game object transform. Transform. So we transform this. Okay. We transform it double wise. So let's see what we get only with 1 point. So you see, you should have transformed this point to the world coordinate point, but it didn't. So something's maybe wrong with Unity, not with me our coding with our code. Okay, so it said that's what the manual says. Transform point. Transforms position from local space to world space. Well, it worked in the first 3 cases, but in the 4th case it doesn't work. It doesn't transform to the global coordinate system, world coordinate system. It transforms to an intermediary world coordinate system, which is local. So it doesn't work. So at least the explanation is not so clear as to what this function, this method does. As all is in so this is well, let's see, intersector 5 6, still not good, not good, not good. There's something wrong with these intersectors. They are not translated. No. as it's supposed to be translated. So my intersector 5x which is here, as it goes to the right, yes, it's 600 on the x-axis. Come on, something's not right. Something's not right. What's not there? Let's see. We have to get, so this transform point parent. Okay, let's check this point already. Okay, barrier mesh, intersector. No, it's not correct. Okay, let's try something else. This game object. Oh my god. Parent. Object not installation of the module. Doesn't have any parent. Okay. Okay. This is somehow stupid, somewhat stupid, because we're not getting the points we're supposed to be getting. We should be getting around the values of minus 216, but we're not getting that. We're getting positives. So either we're not using this transform point method as we are supposed to use it, or something else is wrong here. Let's try this again. What does Google say about this? Does not really transform point to world coordinate system. N-are tot incorect. Like the title says, transform point is returning the correct value. For some values of the variable point, it's off by a little. Some, it's off by a lot. Don't worry about the other variables and such. The variable world point returns incorrectly. Okay. Are you sure you did not rotate the game objects around X or Y? Also, you did not have the screen view camera rotated at any angle. Do you work in 2D mode? What exactly do you do with those world space positions? Keep in mind that transform pointer still returns a vector 3 and you just ignore the z value. Uh, if there are some rotations involved, the position would be off. Do you have any screenshots? Have you tried debugging the actual... Come on. Don't be... so this is our mesh. Nothing shady going on here. It's simple. Nothing's rotated, okay? It's all parallel to each other. There's no rotations involved, okay? It's all not messed up, so we shouldn't have any problem because of something like this. So this guy had a problem and nobody could help him, not even God. Transform point. In the Unity API, it describes transform points as follows. So this guy had the same problem as us. Transforms position from local space to world space. Then it lists the following example code. But if transform point converts local coordinates to world coordinates, then how would this instantiate to the right of the game object? And not simply 2 units to the right of the world space origin. Yes. I'm not sure if I understand your question fully, but it's exactly because transform point converts from local coordinates to world coordinates that the new object is spawned to the right of the current object. Let's say that you hold your right arm straight out to the side. The local space coordinate 2, 0, 0 is at the tips of your fingers. No matter where you go or how you orient yourself, as long as you keep your arm straight out, the tips of your fingers will still be exactly the same location in local space. However, as you move and reorient yourself, the world space position of the tips of your fingers is constantly changing. This is what transform point does. It takes the local space coordinate 2, 0 in this case and converts it to world space coordinate based on the current transform for the object being in your example. I don't know if that clears things up at all, but basically that's what's described in the example you passed. Post is indeed the expected learn. Okay, so let's look this again. Maybe we're not doing it properly. So intersector 10 and 5,6 right now, 10 and 5,6 should be almost the same as the start V and V x axis. So start V and V is minus 216 and our mesh intersector 5,6. You see 5 where is the mesh? Why is it 0? Intersector, why is it 0 now? It's 0 now. Why? Let's do it again so it becomes 0. Okay. Okay. So the mesh now would it should start here retreating. Good. So now our intersector should be, but it isn't. Should be minus 216. But it's this weird coordinate system. If we don't transform in anything, it's 0. So what the hell is going on? Hmm? Oh, this might be the answer to our problem. So this guy says, Lil Ninja. I think the description of the Unity manual is not detailed. Transform point, transform position from local space to world space, which the position is based on the transform local space. This means the position is relative to the current transform local space. The current transform is the origin point of the position. Understand? Transform. Does it have a transform? Okay, let's see. So let's check our intersector point. Is it good or is it bad? It's still bad. It's not the correct point. Okay. Okay. Get Transform root. Okay. Transform root. Let's use this. Any problem? No problem. If there's no problem, let's see. Maybe this is the solution. Using transform root, barrier mesh, intersector. Nope, nope. Still doesn't. Why is this so weird? The only change was that y-axis is modifying also. Nope. Nope. Hmm. This game of the transform parent. So let's see. Barrier mesh. This will be here. Parent. This is barrier mesh, and barrier is another parent. Parent, and then we'll find child. Let's find child. Find child. Find child. Now we need to. Oh, next to the child transform. Find. Okay. So blocker. Transform key. transform point. So so now we need the name. Starts with knowledge. So it's if it's get child, we need to get child okay. So which is the child? It's 0 1 2 3 3. So we need to get child 3. Get child 3. So not this. Get child field 3. Transform. Let's try it this way. First, see if we get any error. Okay. Still not wanting to doesn't want. Something wrong with this. Jesus Christ. Mesh. Mesh. Oh. The mesh filter is HL 0. This game nope. Still the same. Still the same. I don't think it's good what we did. So I'd like to get world space coordinates for a specific mesh vertex. Transform point seems to be what I need. However, I'm unable to get the correct position. In the scene I have an object called head, pos 0 scalar, and I'm trying to get the position vertex. Let's check our skill. What skill do we have here? Scale 1, no problem. Scale 1, no problem. So not no scale which is different from 1. You're using the transform from the scripts game object rather than the head game object. Oh, nation. Sure? You sure? You sure? Transform the child. What's the problem? What's the problem? This transform the child. Okay. Transform. Good. Oh, go. The same thing. I'm gonna make a little pause, then return.